Let us continue with the working of balanced ring modulator. We have just now concluded that it is the carrier signal that will decide the switching of the diodes. Let us first consider the positive cycle of the carrier signal. If I consider the positive cycle of the carrier signal, then as we can see from the diagram, this positive cycle which will appear with this polarities plus on the left, minus on the right, this positive cycle will be going as positive cycle on the anodes of D1 and anode of D2. So you can see the positive terminal, which is the center tap terminal right now, will be connected to anode of D1 and anode of D2. So if this is the case, as we have discussed previously, because positive cycle goes to anode of D1 and D2, both D1 and D2 will become forward biased. So which are the diodes that become forward biased in this positive cycle of carrier signal are D1 and D2, and hence we will replace them with a short circuit. On the other hand, if you observe, the same positive cycle is going to the cathode of the diodes D3 and D4, or in other words, you can see negative terminal of the positive cycle will be going to the anode of D4 and anode of D3. So when there is negative voltage on the anodes or positive voltage on the cathodes, then those two diodes will become reverse biased, and hence in this case with the positive cycle on, D3 and D4 will become reverse biased, and hence we will replace them with the open circuit. So how will the equivalent circuit look like? Let us see how will the equivalent circuit look like. In the equivalent circuit, we will show two diodes D1, D2 forward biased and two diodes D3 and D4 reverse biased. So this is how the equivalent circuit will look like. As you can see, we have replaced D1 and D2 with short circuit because both the diodes are forward biased, or they are on in different words. And the diagonal branches are absent because the diagonal diodes D3 and D4 were reverse biased, and hence we have open circuited the two branches. And you can also see the polarities right now. Carrier is taking positive cycle with positive polarity on the left terminal and negative polarity on the right terminal. Now in such a case, if I apply modulating input signal, let me take modulating input signal as Vi. In that case, you can see there's a direct connection between input and output terminals on both the sides, and due to this my output signal VO will be exactly same as VI. I repeat, there is a direct connection between input and output terminals with exactly the same polarities, no difference in the polarities. So my input signal will be simply passed to the output side. My input, which is the modulating signal, I'm calling it VI. So my output VO will be equal to VI. This is happening because both the diodes D1 and D2 are on, and the cross branches, the diagonal branches, are acting open right now because those two diodes are reverse biased.